Good afternoon, everybody, and welcome back to the development of FlagShip game. The last time we met here was almost 2 months ago, because the FlagShip game is a game developed during a crowd coding experiment conducted during Europe Code Week, which took place in October 2014. So what happened is that in the first day of the week, actually it was a Saturday, because the Code Week started on Saturday and ended on Friday of the second week. What happened was that the specification of a game was disclosed, and then we started involving people in the development of the application in order to have the application released at the end of Code Week. And this is exactly what happened, because we were able to involve more or less 500 people during Code Week in the development of FlagShip game. And we succeeded in the attempt of releasing a Code Week edition of FlagShip game at the end of Code Week. And Vice President Neelie Kroes launched the Code Week edition in an event which took place in Rome on October the 16th. Well, however, the experiment didn't end at the end of Code Week. In fact, the experiment is still open, and the Code Week edition is not fully compliant with the specification. Or actually, it is compliant, but there are features which are additional features which were not implemented in that very first edition. So right now we are keeping developing the application with the same intent of getting involved as many people as possible. And it is also worth mentioning that all the steps of the development of the application are documented by video logs, and all the steps are conducted in live streaming. We are using Hangouts on Air today, and we use similar tools during Code Week. So this means that everybody can follow the development on their own computers, because we are using a development platform which is fully available online, and it is in particular the MIT App Inventor version 2, which is available at this link, ai2.appinventor.mit.edu. You can log in using your Google account and open your own projects. And if you want to keep developing FlagShip game, instead of starting from scratch, which is very hard, because FlagShip game is quite a complex application for the typical applications which are usually developed using App Inventor. So I suggest to start from the result of the last step. If you go to the flagshipgame.eu website, you find a roadmap, and the roadmap contains all the video logs of the coding steps, together with the results of each step. And the results are not only the actual package that you can install on your Android device to try it out and possibly play with the game, but they are also the open projects that you can import into your account in App Inventor. So if you scroll down this page, you see all the development steps fully documented, and the last one, right before the release of the Code Week edition, is the one that we are using today as a starting point. So please download this project and import it within App Inventor in order to follow what I'm doing step by step. And this is the link of today's meeting. As you can see here, I have an emulator in order to show the result of what we are doing. And instead of using an emulator, you can use your own Android devices to test the application as soon as you develop it. So let's move to App Inventor, where I already imported and opened the FlagShip project. And this is the status of the project that is currently available on the Google Play Store. So let me show how it works. I built the application using this feature here, which allows me to download on my computer the APK, which is the package that can be eventually installed on an Android device. And instead of installing it into a real device, I install it in the emulator in order to show you how it works. So to this purpose, I have just to drag it and drop it here, and it will be installed and launched. And here is the first page of the application. And as you probably remember, there is a small animation here, that is this one. So I can stop the animation and either click into info or play the game. If I click into info, okay, this is just an information page that was the only page available when we first published the application before actually starting the crowd coding experiment, while the main page is the one that is accessed by pressing on play the game. And notice that for each one of these three screens, there is also a different screen here in the development tool. Screen 1 is the default main page, which is this one. Info is the page that we entered 2 minutes ago, while gameplay is the page where we are right now. Notice that it doesn't look exactly as this one, just because most of the adjustments of the graphics have been done into the coding part, not into the interface part of the development environment. So right now we are using what is called the designer, which is this one. But if you go into the blocks editor, then we find the code. And the code is quite big. Actually, I would say that it looks huge in the sense that it doesn't fit into the screen, even if I reduce the font a lot. So let me show you how it works. As you probably remember, what happens is that there is a timer here which becomes red after 60 seconds. And then there is a best score which is recorded on your device. And there is a score which starts by 1. And what you have to do is to sort by touching the flags which are proposed in alphabetical order. So this means that if I touch this flag, then it is labeled 1 because it is indeed the first flag that I touched. But if I press another one which is not in the proper alphabetical order, it just disappears. If I press another one which is instead in the proper order because it follows the first one into the alphabetical order, then a new number is added as a flag. And we can keep pressing or touching in any order the flags, and if we touch them into the proper order, then these labels are added. And all the labels that we have at the end compose the actual score, which is obtained by multiplying all the labels. But unfortunately, the labels are associated only to the correct touches. So this means that if the first touch is corresponds to the last flag in the ordering, then no other labels will be added. while if the first touch corresponds to a flag, the country of which has as a name which starts, for instance, by A or B, then this would be a very good move, because there will be a lot of other flags following in the ordering. And then the score is also divided by the time, actually by the excess time with respect to the 60 seconds, which are assumed to be the default. So this means that at the end of a turn, of a game turn, of a match, your score will be the multiplication of all, the product of all the labels divided by the seconds that exceed 1 minute, or multiplied by the seconds left to 1 minute, in case you took less than 1 minute. Okay. What is missing are two main features. The first one is this one. This is a button, you see. This is sensitive to the mouse click, which corresponds to a touch into the real device, but nothing happens just because the hint is not implemented. And the other one is the suggestion, which is here. This is supposed to show the value associated with the next flag in the ordering. And since the ordering right now is just an alphabetical order, which is the sorting criterion used as a case study for the development, this means that the value associated with a flag is the name of its country. So we would like here the application to suggest which is the name of the country the next flag belongs to. And this would be of great help, because it will help us figure out which is the next flag to touch. Okay, so what we are doing today is to implement this feature. And notice, please, that this is not a tutorial on how to use App Inventor, because I assume all of you to be already able and quite expert with App Inventor, because today we are developing a functionality which is not trivial. So we are thinking about an algorithm, and then we are implementing it into App Inventor. But we are just using App Inventor, not explaining how it works, because we need to focus on the algorithm and on its implementation rather than on the development tool. If you want to follow a tutorial on App Inventor, you may find many on the internet, or you can even use the previous development steps, which were less complicated and also quite self-explaining. And notice that the entire collection of video logs of all the steps that brought us up to this point can be considered to be like an online course, in the sense that they really allow you to possibly rebuild the entire application from scratch. So this means that if you follow them step by step, you will end up knowing pretty well how to use App Inventor to do something which is not trivial. Okay, let's start. So we need to move into the blocks, because we have nothing to add to the interface, because as you can see, there is an element here in the interface that was added, which is right now represented by these 3 dots. And if we go down, we can find it here, and it is this one, nextvalue. This is a label as an interface element, and the label is just a text that can eventually be changed by the code. So we want in the code to change the text of this label in order to show the name of the country corresponding to the next flag in the ordering. Okay? Okay, let's switch to the block editor. And here we are. Okay, it is quite hard to figure out where to implement what you need to implement, because this is quite a lot of code. There are many procedures which were defined, and the procedures can be collapsed in order to make it easier to develop new pieces of code. So what we want to do is, at each step during the game, to show which is the next flag to be pressed. And to this purpose, we need to figure out which is the flag which follows in the alphabetical order, or in general according to the sorting criterion. So let me show you which are the variables that were used in the code. In particular, once the game started, we are using just these variables here, which are lists. Selected values is a list which contains 16 values. In this case, values are just the positions of the flags in the ordering, and selected labels, which contain the corresponding labels to be shown. So labels are the actual names as they have to be shown to the end user, while values represent the position in the ordering. Okay, so those are called values and labels, while these other variables are called selected values and selected labels. You probably remember why, but let me just remind you why. Because we are not playing just with 16 flags, while we are displaying only 16 of them at a time. The entire amount of flags, as you can see from these numbers, is 38, because the CodeEU edition is based on the 38 countries which took part in CodeEU. But on the other hand, at each time a game is launched, 16 out of 38 flags are randomly selected and randomly placed into this 4x4 grid. So selected values and selected labels contain just 16 of these and these values. So this is kind of a sub-list, and they are also randomly sorted in such a way that the flag that we find in position 1 does not correspond to the first flag in the ordering, but to the flag which has to be displayed in this position here, while this is position 2, 3, 4, 5, 6, 7, 8, and so on. So this means that while these ones are sorted according to the sorting criterion, the selected values and the selected labels are sorted according to the position they have to take into the grid. So in order to display here the name of the country which follows in the ordering, we need to know which is the last flag which was touched, and then we needed to find the flag which follows in the ordering. So assume, for instance, that we touched a flag which position in the overall ordering is 12. Okay, if the current value is 12, then we have to suggest which is the next one. And we don't know because we are not sure that there is among the 16 selected flags the one corresponding to value 13. So what we have to do is to look at all the flags which have not yet been pressed to see which is the value associated with them, and among all those values we need to choose the minimum of the value which exceeds the current one. So let me say it in other words. If the current value is 12, we need to look at all the values which are greater than 12, and among all of them we need to choose the minimum. But unfortunately we are not working in a list which is ordered, but we are working with a sub-list which is not ordered according to this sorting criterion. So what we will do is to visit all the elements of this list, which is selected values, in order to search for the next element in the ordering. Okay, and to this purpose we define a new procedure which is called nextVal, and which will return the label to be displayed here to suggest the next country. So let me put the new procedure here, and let me call it nextVal. Oh, sorry, not nextVal, but next label, because is the label that I want to display, not just the actual value. In order to find the next label, I need to know which was the current one. And to this purpose, I add an input to this procedure, and I call this input variable current. So this means that I will invoke this procedure by passing the value of the current element in order to make the procedure able to return the next one. The next label which has to be returned will be defined here, and in particular I go into this menu here and I choose this block to initialize a local variable called next label to an empty string. So into the text menu, I take an empty string and I place it here. Then I have to write here the code which does the search that I need. So the code which will be used to search for the next element. I go into the control panel and I take this block here, which allows me to write some code in here and eventually return a value. The result will be the value returned by the entire procedure. Then I need another variable, another local variable. Notice that I call those variables local because they exist just within this block. This means that if I try, for instance, to use a set variable here, I don't find next label, while if I do it within the block, then I will find it. Where is it? It's not here. Let me do it this way. Okay, here it is. While if I put it here, as you can see, it tells me that this is not a valid item, so a valid element of this list. Okay, now I need another local variable, but this time I don't need a local variable to be defined and initialized as a return block. So I use instead this other block here. And the variable that I initialize here is the one which contains a candidate next value. And the candidate next value will be set to -1. Notice that the search will be based on the values, while the return will be a label, because we need to compare the values and we need to display a label. So we have two arrays or two lists, one of labels and the other of values. We do the search on the values and we return the corresponding label. So this means that these two lists have the same order, so that if we find the correct position of the next value, then in the same position we find the corresponding label and we can return the label. So next label will be the returned value, while next val will be the local variable used to search for the correct element. So this means that next value is the value to be compared with current, which is the current value associated with the last flag that was touched by the user. Okay, right now what we need to do inside this block here is to span all the positions of the grid to search for the correct value. So we go again into the control block and we take a for each instruction and we call k the counter which goes from 1 to 16 one by one. So this means that this is an iteration, this is a loop, and the instructions that will be put inside this block will be executed 16 times. The first time, k will take value 1. The second time we execute the instruction within this block, k will take value 2, then 3, then 4, and as it reaches 16, this will be executed for the last time, and then we will exit this loop. Okay? And what we need to do within this loop is to compare the value which was the previous value of next val. So next val represents the best candidate value with the value associated with the flag in position k. So position k means position in the grid, 1 being year, 16 being year, and the grid being visited row by row. So 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay. So as I mentioned, we need to look for the next flag, considering only flags which have not been pressed so far. So to this purpose, I need to have a flag which tells me whether or not a flag has already been pressed. So to this purpose, I use a global variable this time, and I call this global variable pressed. And this variable will be not just a variable, but a list of flags, or a list of values which will be 0 if the corresponding flag has not been pressed, or 1 if it has been pressed. So I create it as an empty list, and instead of initializing it here, I initialize it into a block, which is this one, in which a new game is started. In particular, there is a get data block, which is this one, which is the one that extracts the 16 flags from the list of 38, and within this block I want also to set to 0 all the elements of this list. So I take this, I put it here, I go into the list, and I select, to make it as fast as possible, this this option here, and then I write all the 16 zeros, 1, 2, 3, 4, 5, 6. Okay, there should be 16, 2, 4, 6, 8, 10, 12, 14, 16. Okay, and in this way I initialize to 0 the 16 elements of this list. Now I can collapse this block and put it back here. And I can use this list of pressed flags, but to this purpose I need also to update it whenever a new flag is pressed. So let me search for the proper position in which to add this instruction. And here we are. You see, this is the piece of code which is executed whenever the grid is touched, and in particular if a sprite, which means a flag, is touched. So each time a flag is touched, we want to not only do what we already did, but we need also to update the flagged, the pressed list. So let me see where to do it. Okay, I would say that we can do it here, because here this is the position in which we find the touched flag, and exactly in this position we can set. Actually, I took the wrong instruction, sorry. The proper instruction that I have to use is the one which replaces an element of a list, which is this one, because I'm not setting an entire value, but an entire variable, but I need just to replace an element of the list. And the list that I want to update is the one which is called the pressed. So global pressed, here it is. The index is the one that I just found, which is called the current. And the new value, which is called the replacement, which is the new value to be inserted into the list in place of 0, is 1, because we decided 1 to denote a flag which was pressed. Okay, right now the pressed list should work properly, and we can really rely on it within this function. So let me move back to the piece of code that we need to implement, and I need another control statement, which is an if, to check whether or not the flag in position K has already been pressed. And to this purpose, I have to compare the element in position K of the pressed list with 0, in the sense that if it is still 0, this means that this is a flag which has not been pressed yet. So this means that we are interested in it, while if it has been already pressed, we do not need to consider it. So we want to compare it with 0. And here we have again to use these, this instruction here to take the proper element to the list. You see, in this way we are taking the element in position K of list pressed, and we check if its value is still 0. If it is, then we execute the code that will be placed inside this block. Otherwise, we do not consider it, and we iterate by increasing K and looking for the next position in the grid. Okay, now if we found a value, which actually an element which is worth being considered, then we use another local variable, which is called val, to take the value associated with it. And to this purpose, we reuse this instruction with a different list, which is in this case the list of selected values, and we take the one in position K. So right now, val is a variable which has assumed the value of associated with the flag in position K. What we have to do is to compare this value with the current value, which is the value of the flag, of the last flag that we pressed, to see whether or not this value is greater or equal than the previous one. If it is greater or equal and it has not been pressed yet, this is a candidate to be the next flag to be pressed. This means that we need another if statement here and another comparison which is a greater or equal than between the current value and the value of val, which is the value of the element of the associated with the position in the grid that we are visiting right now, which means position K. Okay, now inside here we have already found a flag which has not been pressed and which has a value which is greater or equal than the current one. So this is a very good candidate to be the next flag to press. But among all the remaining flags which meet these requirements, we need to find the best one. Which is the best one? The best one is the one which has the lowest possible value. Assume, for instance, that we pressed the flag. Okay, let me restart the game and show you what happens if, for instance, I press this one. This is Austria. This means that it starts by A, so this is a very good first move, because all other flags follow in the ordering. Now, this one is a very good candidate because this is Belgium and it starts by B. If instead I press this one, this is Turkey. This is another candidate which meets the requirement of being greater or equal than Austria in alphabetical order, but it is not for sure the best move because this is not right after Austria, but it is at the very end of the ordering. So this means that here we do not want only to find an element which follows in the ordering, which is what we did so far, but we need also to find the best one. And the best one is the one which has the minimum value among all the elements that meet the requirements checked so far. Okay? So to this purpose, we need another if statement. And here we need to double check whether or not the current value is less than the previous one, the previous candidate that we had, which will be stored into nextval. If this is the case, then nextval will be updated and it will take the value of element in position k, which is this one. So in practice, if this happens, then nextval will be set to the value taken by this one, which is this. Okay, so this means that by doing so, what we do is to make sure that the nextval takes the value of the best possible choice starting from the point at which we already are, which means starting from the last flag which was already touched by the end user. Notice, however, here that this works properly in updating nextval, assuming that we already found at least one candidate. But the first time we enter this function and we enter this loop, nextval takes value -1. And since all the other values are positive numbers, there will be no value less than the original nextval, which is -1. So this means that the first time we enter this loop, we need to treat it as an exception, and such an exception can be recognized either because next value still takes value -1, or because the label, next label, is still empty. So let's use, for instance, this condition here, and if we go into text, we find is empty, and we can apply this function to next label, Okay, this tells me that I have to use it inside here in order to have this variable available, but I need to figure out where to use it. So I need to use it here because this condition by itself is not enough. Instead, I need an operator which is a Boolean operator, or which tells me that I have to update the next value either if val is lower than next val, or if I am executing this instruction for the first time, and this is the condition which tells me that I'm here for the first time. So right now, the first time I execute this instruction and I update next val with the value in position k, even if it is not less than next val. Okay, then I have to do to execute another instruction here in order to make sure that also the next label is updated accordingly. And to this purpose, I use a set next label instruction, and the value to be associated with next label has to be taken from another list. Oh, sorry, I have to duplicate all of this. Another list, which is the list of selected labels. So notice that at this point, I found that the value in position k is the best candidate so far. So according to this, I have also to take as next label to be displayed to the end user the label which is stored in position k of the list called selected labels. Okay. Now, next label has been properly set at the end of this loop, and this means that I can get the value of next label and return it. So I'm not sure that it works because this is quite a complex piece of code and we needed to test it. But in order to test it, we need to call this procedure. So we need to figure out which is the position in the original code in which this function has to be called. We go back to this piece of code, which is the one that we edited before, which is when grid is touched, and we can find here that there are many cases in which the code is split. In particular, here we have the case of a correct tap, which means the case in which we tapped a correct flag. This is the case in which we tap the wrong flag. What we need to do is to display a new best tap, only a new suggestion, sorry, only when we tap a good flag, because otherwise the flag just disappears and the best next flag doesn't change. So let me show you what I mean. Right now I pressed on Turkey, so the next flag is for sure one that follows Turkey in the ordering, if any. And this means that if I, for instance, press on Hungary, then there is no reason for changing the suggestion of which is the best flag to tap after Turkey. Okay? So let me show it to you again. Unfortunately, this was not a good example because there were no flags following in the ordering. So let me restart the game and see what happens if I, for instance, pressed Latvia, and now if I press Serbia, this is good, and the next possible flag could be, for instance, United Kingdom, and it is still, oh sorry, it was Slovakia actually. Then there is, okay, there are many, but if I get rid of them, okay, for instance, Sweden, okay, at this point, it is really United Kingdom. So this means that there is no reason for changing the suggestion, which should be United Kingdom, if I keep pressing wrong flags, which just disappear. Okay, so this means that the proper position in which to place the call to that function, which is called the next value, and that will be used to update the label next val, is inside this condition here. So let me go and find the label that we need to update, which is this one, next val. And we use this instruction, which sets the text associated with it. And in order to specify the text, we go into the procedure menu, and we invoke call next label, passing to this procedure the current value. And the current value is obtained in this way. I go to the list of selected values, and I take the one in position current, which is the one corresponding to the flag that was pressed when we entered this condition here. Okay, it's time to try to build the application and to test it. So let's see if it works. Still building the application. In the meantime, I can exit the previous version of the application from the emulator. Okay, here is the new package. I drag it and drop it into the emulator, and there is the game. Okay, notice that there are no suggestions the first time. So if we want to add a suggestion, we should do something different. And let's see if it works when we press the first flag. Quite good. So right now we find here a suggestion, which is Croatia, and we can follow the suggestion, assuming that we know the flag. So notice that the suggestion doesn't tell us which is the flag to press, but which is the value. Right now, the value corresponds to the name of the country, just because we are using alphabetical order. If, for instance, we were proposed to sort flags according to the population, then it would be much more difficult to play the game, because the suggestion of the next value would represent the population value, and we should find the flag which corresponds to that specific number of people living in the country. So right now, Cyprus is here, then there is Finland, and so on. So let me show you what happens if I do a wrong move. So for instance, if I press on Romania, then the next one will be Slovenia. And now if I press on Greece, then Greece just disappears, and the next suggestion doesn't change. If I press on Spain, then it changes, just because the next one will be Sweden. Okay, here it is Sweden, and now there are no more suggestions, just because there are no other countries following in the ordering. So let me see what happens if we finish here and we restart the game. Okay, you see, again, it works properly. Now, if there are no more suggestions, I know that I have to press as fast as possible all the flags, because there are no more flags following in the sorting criteria. So I have just to finish the game as quick as possible. Okay, we need just to figure out how to provide a first suggestion. So how to suggest the first flag to press. To this purpose, we go into the procedure which is executed at the beginning of a match. Which is the restart one, which invokes a new game. So we have to look for a new game. Here is the new game, and we can set the value, the initial value of the next val, which is the suggestion here. And to this purpose, as we did inside the piece of code executed whenever the screen is touched, we have to call the procedure which is called next label, and we have to pass the current value to it. But since this is the first time we call it, because this is the very beginning of a new game, then we do not need to take it from a list. Instead, we can specify a number which is for sure lower than all the real numbers. And since we are playing with positive integer numbers or positive numbers, any negative number is a good candidate. So here, as a current value, we can set -1. Okay, even if we made a very small change, we need to rebuild the application and to test it again to see if it was effective. Notice that if you are using a real device, you can even synchronize it to the development environment using the connect functionalities, and to this purpose you may be able to test in real time all the changes that you make on the code. This works fine for small applications. For multi-screen complex applications, it doesn't work very well. So sometimes it crashes. That's why I prefer to build the application and test it. Okay, here is the new version. Let's play the game. Great, it works. So right now we have already a a suggestion as the game starts. Then if I, oops, I took exactly the last one, so there are no more suggestions, so I have just to get rid of all the flags as soon as possible in order not to spend too much time. And this was a run of the game. Here we have Belgium. Let's follow the suggestion, press on Belgium, then Croatia, and so on. And then there is Finland. So I can keep following the suggestions, or otherwise I can press something which is wrong, and this means that at this time I have just to press United Kingdom, which is the only one following, and all the other ones will be wrong tabs that doesn't bring any score. Okay? Okay, that's it for today. Next time we will try to implement the hint function, and pressing hint will make a mark appear on the screen and visit all the flags in the proper order very fast and then disappear. So this means that the hint button may allow very young people to play this game as a memory game, just to try to follow to redo what the mark did on the screen when we pressed the hint. Okay, thank you very much for your attention, and see you next time. Bye.